All right. Before I start, I am not in Oxford. I'm way on the other side of the world. I live in the state of Minnesota in the United States. So it is 2 o'clock here, and I am insanely jealous of seeing all the people that were on camera drinking beers or having wine because it's a little too early for that. And I actually have to go somewhere with my son later this afternoon. So unfortunately, I can't do that. I'd actually like to be there. And my international travel has so far been Canada and Mexico, which really isn't a lot. I would love someday to be over there somewhere, um, either in Oxford or a neighboring city. I need to expand my travels, but we have this technology and that works well, so that's pretty cool. So in any event, I will start with my presentation, which again is using source generators for fun and definitely profit. I'll keep changing that as we go on tonight. My name is Jason Bock. I am a developer advocate at Quicken Loans. And here's a little bit of information about myself. I have a link to the slides, so that'll be on the next slide. So you can get all this stuff later. I will be checking the chat as I go on through the presentation. So if you do have questions, feel free to put them in chat or just come off mute and say, hey, Jason, get my attention, and I will definitely want to take those questions. One of the things that I think we all know about COVID-19 and pandemics and having to do all this virtual is the interaction sometimes isn't the best, though I have to admit this group has probably been one of the most talkative ones I've seen so far that I've been in the virtual world, which is great. So I'd like to continue that. If you got questions, please just feel free to ask. I'd be happy to try and answer it as best I can. If something does come up later, just send me an email at that email address that's at the bottom there, jasonarbach@outlook.com, and I can answer it offline then. So here's all the downloads. The last one on the list, again, is a link to where I have all my presentations, this one included. So you'll be able to find that and download it if you'd like. Those 4 there are what I'm going to be doing in the demos. The first one basically drives the other 3. That's just the vehicle to kind of show how this stuff works. And then the other 3 are where I'm going to be diving in a little deeper. Okay. So you can take a look at the code and see how all this works. So I'm going to spend a little bit of time on the what and the why of source generators and what makes this all really cool. I personally love this feature. I find it to be really, really fascinating and enabling. So we're going to go through a little bit of why this is something we want to talk about. Most of the talk is going to be on demos. I'm going to spend a lot of time in code and going through showing how this all works and what you can do with source generators. And then at the end, we'll just wrap it up with a call of action. Okay, so the what and the why. We're going to start with the what, just the 101 of source generators. What are they? What do they look like? The analogy that comes to mind for me in terms of source generators is a factory. When I was actually done with school and I was going to college, I would work in the summers in a factory, and it was kind of an interesting experience because I got to see how you literally take molten metal and fabricate the parts and trim them and go through an assembly line where you end up taking more parts and you kind of just all put this stuff together, and out the other end becomes a product that you want to sell. And that's what I kind of think of what source generators are in a way, in that you're taking code as your intake and you're going to go through the source generator and look at that code, and out the other end is going to come new code. And I use these words on purpose in that a source generator doesn't allow you to edit code. So it's only additive. So you can't change method bodies. You can't delete code that currently exists. That's call it a restriction or a design feature, depends on the way you look at it, of source generators. The feature of source generators actually has gone through years of work at Microsoft, especially in the C# team. if anybody's out there that follows what the C# team has done over the many years, and especially now that they've been in open source, there was an attempt to do this where it was almost full-fledged metaprogramming, and they had these keywords called replace and original, and it was quite powerful, but it also, for a couple reasons, I think it went a little too far for what they were looking to support for the majority of people. And so they kind of went back to the drawing board. They came up with this idea of source generators. And even though it sounds restrictive that you can't do that kind of all the way change everything that you want, there's still a lot of things that you can do with source generators. There's kind of an edge case here in that if you use partial classes, you get sort of the effect that you're editing the actual definition of a type, which is sort of true, but you can't change what's currently there. You can only add on to what's there. But it's not just code that you can look at. There are things in CS project files called additional files. And you can look at those files and use that information like a JSON file, if it's an additional file, read that and use that to build new code. You could look at a database or you could look at a service. It doesn't really matter because the generator itself is, sorry, I got a call and I thought I hung it up, but I didn't. The generator itself is just C# code. So whatever you want to do in your C# code, that you typically would do, you can do within a generator. You do want to keep in mind, though, that this is running during a compilation phase. So you don't want to do something that's too taxing, because if this is going to be used while somebody is editing code within Visual Studio or Writer or some other IDE, you don't want that to be a bad experience for them. But the sky's the limit. You can take a lot of different input sources, but you can only end up with new C# code. And right now, you can't create an artifact that is anything but C# code. So unfortunately, right now, you couldn't create like a proto file if you wanted to do that, or a JSON file. I just read today that apparently in the next version of .NET, in .NET 6, the compiler may be getting a change to allow you to create different kinds of artifacts, which would actually support the notion that you could generate more than just a C# file. Okay, but right now with the version the way it is, it's just new C# code. Okay, so that's the basics. Why do we care about this? Why is this to me such a cool feature? There's two things that come to mind. The first one is that you have a really good opportunity to address performance issues in your code. Okay, if you've ever written any code that uses reflection, for example, I love reflection. I think it enables you to write some really powerful code that's generic, not in the sense of C# generics, but generic to work with a whole bunch of different cases in a one-stop shop way, if you want to think of it that way. So that's cool, but there can be, and I have to hand wave a little bit here, there can be some performance implications for doing that. It depends on the context of what you're doing and how much you're running reflection. Performance is somewhat related on the end result. Is it deemed fast by your users? All those types of things. But there can be typically a measurable performance hit if you're using reflection. And what's nice about source generators is it gives you the opportunity to potentially remove that reflection code and bake in the fastest path for what you are doing in your application. And I'll show a demo of this later on. The other one is removing these rote tasks that you do as a developer where you know how to do this. It's not that difficult to reason about or think about, how am I going to do this? Like if you think about equality, how do I implement equality in a class? Well, you need to override equals and get hash code and probably the equals and not equals operators and You probably want to implement IEquatable and do those types of things. It's not a huge list to keep in mind, but it's stuff that's really not the fun stuff. That's not the stuff that's interesting. We want to solve bigger problems. We want to solve more complex problems. And this rote stuff, if we can automate it so that we don't have to think about doing it, so much the better. That's time that we're saving. So let me illustrate this in a little bit more depth. Let's say that you had to implement iNotify property change. This is where if I was in the room and I'd ask people who's implemented this, I'm sure I would see some hands be going up for this one. iNotify property change is an interface that makes it kind of a standard way for an object to state, my data has changed from this property, okay? To implement iNotify property change isn't that difficult. It's fairly straightforward, but if I just want to state that the name property has changed in this case, there's a lot that I have to do. I have to have a private backing field that I can check to see if it's different from what's coming in on the setter. And if it is, make sure I call some method that's going to raise the event to let observers know that that value has changed. Okay. Not hard, just tedious. It's that tedium code that we don't want to do. What if you could write this? Instead of writing all that code that you just saw here, if I could do something like this, so much the better. I take all that stuff and I put it into essentially one attribute. So now all I have to do is create a field and attribute it with this attribute. This is actually in the last slide of my presentation. If you look in the notes section, I have references to a bunch of links that you can take a look at later. And one of them is to some examples that Microsoft themselves have done for source generators. iNotify property change was the big one. That to them was the baseline. If source generators was considered to be like a success, or at least something that met their goals, implementing iNotify property change was one of them. And so this is how they did it. You can do it a different way if you want. But what they did is they said, okay, put this attribute on your field and we'll handle the rest. Okay. So this is addressing that one part, getting rid of that tedium code so that it's very easy for you just to say, I've done this and I can move on. What about speed? Again, if I was in the room, I'd ask, who here has used Auto Mapper? And while the code in the top and all the code in the slide isn't from Auto Mapper per se, it's that idea of being able to say, I've got a source object and a destination object, and I want to take the data from the source and map it to the destination. That's what Auto Mapper does. It's a very popular NuGet package. I think it has over 100 million downloads. So a lot of people have used that one. Okay. And it works fine. And it's been fairly optimized and it does a good job of what it's supposed to do. So one way you may do it, if you had to write that code yourself, is something like this. Now, I'm not going to get into the details. In fact, as I am looking at this, I'm looking at the first if statement in my slide and going, I forgot the end curly brace, so I got to fix that later. But the intent is, if you had to write something like this in a generic way, you might use reflections so you could find all the properties that are gettable and settable, and then find matches between the two so that you can set values on a destination from the source. Okay. That's great. But if I could do something where I bake in the path for a particular source to destination, I'm going to get an optimization here, because I don't have to have reflection go through all of the churning that it needs to do to figure out what those matches are. If I figure that out in a source generator, I can produce this code, and that's going to be about as fast as I can get it. Okay. Now, if you are interested in source generators, especially if after I go through the demos and you look at these and you go, this is kind of interesting, I want to start building these myself. There is an investment in time, in that if you've never looked at the compiler API or Project Roslyn, there's going to be some education that needs to be done. And I've used the compiler API now for a while. And even at this point, I still feel like I'm a novice. It's a exhaustive API. There's lots and lots of stuff there. And I feel like every time I try to build something new with it, I'm learning something new. So it's, don't underestimate the time to take to learn it. I don't want to discourage people from that either, though. It's not like it's an impossible task. It's just, it does take a bit of effort to understand what a syntax tree is, what a semantic model is, how do I parse code, how do I, change a tree or look for what I'm looking for in the tree, how do I do that? But once you get those things in place, that's where the profit comes into play. Because now you've got a really powerful tool that you can use in your code to solve problems that are kind of along the lines of what I just stated, or just make something unique, make something interesting. Okay. So that's the profit part. So let's actually spend now some time in demos and see how this works. I'm just going to take a quick check here to see if there are any chats. Let's see here.
I think we've got a couple of questions.
Let's see. When you say different, oh, that's surprising. Question for the end. You can find out the clue as possible. How clue code from another project. Switches two separate generators, both of them use shared code in a third project. How the generator calls the shared code throws an exception. Jonathan, I'm not quite following that. Let me just read it here real quick again. It's possible to include code from another project. Well, I don't know if this is going to answer it. I will show this in the demo. There is a way to persist or save the code that's done from a source generator. So I'm not sure if that's what you're looking for, but there is a way to do it. And I'll show you that setting in the project file. If that's not going to answer your question, then maybe ask it again, and I'll see if I can tease out what you're getting at. Automate, property change. We can work with related properties. I would look at the example, Richard, that comes from Microsoft. Again, if you look at the notes section of my last slide, that will lead you to what they did. To be clear, though, that doesn't mean that's the only way to do it. They just said, hey, I've got a field. I'm going to put an attribute on it, and that's going to generate everything for us. But that doesn't mean that's the only way to solve it. That's just the way they did it. Okay. So is there a way to conditionally generate source? Yeah, you can. There's ways that you can read from MS Build in terms of property settings, or if you had an additional file, you could use that as well. There's lots of ways you can read to say, if I am in a certain setting or in a certain context, then I will or won't do this. So you can do that. It just depends on how you want to find what the condition is. Okay. All right, so let me go into the first example. And this is actually what I call inline mapping. This is my own mapper that I wrote so that I could kind of show off how a source generator works. And with this first example, I'm going to spend more time on the mechanics of a source generator and kind of go a little bit step by step with it. The other two, I'm just going to show how they work and just show the features that you can end up having if you use source generators in your code. All right, so let me go over here and I will bring up the demo project first, and I'll go into inline mapping. So the first thing to notice is that we have a source class here, which is pretty simple. It just has these three properties, and you're noticing there's these code lens reference errors up in the top. That actually is a bug, and I'm not kidding. I saw this come up with the 16.9 release of Visual Studio. This started firing on me all the time, and I'm like, what is this? Apparently, this is actually a bug in Visual Studio that if you are using a source generator to generate code, there's something within code lens that it throws an exception because it doesn't understand how to handle the source generated code. I don't know why, but other people have seen this as well. So apparently it's going to get fixed in 16.10. So anyway, I can get rid of them and they're just going to come right back. So just ignore those yellow errors at the top. So we have a source definition here with three properties. We have a destination with 4. So this reason one isn't going to get mapped right away. Okay. So I'm going to make a source. I'll print out its information. Then I've got this map to destination, which is an extension method. And I'll eventually show you what that looks like. And then we're going to print out the destination. So let me just run this quick, so you can take a look at what this eventually looks like when it's all done. And you'll see here, there should be two lines that are going to get printed out. One that has the source information, and then one has the result, except the result won't have the reason set. That's where that little comma is there, because we didn't have anything to look at. Okay. So how does this mapping actually work? I'm going to dive into the actual source generated code, and then we'll see how I actually did it within the project itself. So if I F12 into this, you'll see that I get this thing up here that says this is auto-generated by this generator, and you can't edit it. So it's another thing to keep in mind. You can't edit source generated code. Okay. Now you can, as I mentioned before, if I go into the project settings, I typically don't have these turned on, but if you do want to save your code in a specific directory, these are the settings you can use to turn that on and say where you want that to go. And then you'll actually have CS files saved. This is off by default. And frankly, I've never needed to save the files. This has been more than sufficient if I'm debugging the code to look at and go, oh, this is what it's actually doing. Okay. We'll get back to debugging in a moment, but this is what the code generated. So how did the source generator do this? So I'm going to go into the actual inline mapping project and close some of these up here. Let's move this over to get a little bit more space. The inline mapping project itself is just a .NET Standard 2.0 project. You know, I've got some other settings in here to make a NuGet package and other things like that. But really what matters is that you're targeting .NET Standard 2.0. The source generator feature is actually a addition to the compiler itself that came in .NET 5. So even though it doesn't rely upon anything specific in C#9, it does rely upon a compiler that understands what a generator is. So that's where the .NET 5 and beyond restriction comes into play. Okay. So that's the first thing you need to do with the project. You'll also need to reference these two packages from NuGet, the code analysis packages, so that you can read all the source tree stuff and whatnot. Okay. This one is just for me for the NuGet packaging stuff. Okay. So not a lot that you need in the project file. The next thing you need to do is define an actual generator, which is fairly straightforward. You're going to implement the iSource generator interface, and you also want to attribute your class with the generator attribute. Okay. Now, when you say you want to implement this interface, there's two methods you have to implement: execute and initialize. Technically, you don't have to implement initialize. If you just want to make it a no-op, that's fine. But for all the generators I've done, I've used it to create receivers. I'll explain what that is in a moment. So those are the two methods you need. Now, execute is where you're going to actually determine, do I generate text or do I generate source text such that that can be included with the compilation process. Okay. So you can see here, the first decision I make is I'm going to look at that context that's given to me, excuse me, by the compiler and say, is that receiver a map receiver? So now we're jumping back to, well, wait a minute, what does initialize do? So in initialize, you'll notice that I'm calling this register for syntax notifications. Typically what you're going to do in your generator is use this to kind of set up a filter. These receivers are going to determine, when the compiler is looking at syntax trees, which nodes you really care about. Okay. In my case, typically what I'm looking for are type definitions that have these map attributes on them. Okay. So in my map receiver, which implements iSyntax receiver, which means I got to implement this method here on visit syntax node. What I'm going to be doing, and I won't go through all this, is in the case where I'm going to say map to, because I can say map to, map from, and I also have an attribute that says map where I define the source and the destination if I want to. In the case of map to, I'm going to say, if the compiler is looking at a type declaration, like a class, look through its attributes and see, is the attribute name map from or map to? Okay. I can't determine if it's the actual attribute that I have defined in my project, but at least I know that this is probably a good candidate to look at in more detail. So I'm going to capture those syntax nodes. And again, this is just like public class source. That's really what I'm capturing here. And then in the generator, when I go back up to the execute method, I'm going to look at that receiver and determine, do more of a deeper investigation and see, can I actually generate code? Okay. So that's what I do in my method here, generate mappings. So in the generate mappings, the next thing we're going to do is look at all of those receivers and determine what source destination pairs I have. Are there any errors between those two? Are there any maps between the two? Are there any properties that map between the source and destination? And I think that's it. I think there's maybe one more thing, but that's essentially what I'm trying to grab from this initial information I got from the receiver. Okay. And again, I'm just going to look at one path here, validate map to, which starts when I start the validation. I'm really looking to, again, find what's in these nodes that I may be interested in. Okay. So if I look at validate map to, what I'm going to be looking at again in my case is type definitions where let's see if I can get this right here. So this is a type declaration syntax. So this is part of the syntax tree. In the compiler API, what you want to typically get to is what's called the semantic model. You can think of this as almost like, it's not reflection, but it's kind of like reflection in that it gives you more semantic information about what's going on in the compilation. And that's typically easier to use when you're trying to suss out what's going on in your code. So in this case, I'm going to get a type symbol. And that type symbol, I'm going to look at all of its attributes. And if there are any attributes that are actually of that same map to attribute symbol here, now I have a match. And when I have a match, what I can do with that attribute is look at its constructor argument and determine, well, what's the destination type? Because that's what I'm passing in. If I go back to the example here, oops, that's over here. And I go down to source, you know, so that's what I'm passing in as my argument to the constructor. Okay. Now, I'm going to pause here for a second because if you've never seen the compiler API, you might be getting a little lost and going, where is all this stuff? If you have Visual Studio and you install the compiler API SDK from the installer, you will get this syntax visualizer window. This is indispensable to be doing anything with the compiler API. For example, if I wanted to say, well, I know I need to be looking for a class definition, I can click on this class here and notice on the left, the syntax visualizer just lights up and says, oh, I'm looking at an identifier token on a class definition. And now when I click on the class definition, all of this gets highlighted on the right. Okay. If I click on constructor declaration, now that just moved me to the constructor of this class. So these are really, this tool is so helpful for me to just literally write some C# code in, look at the syntax visualizer and go, oh, that's what I'm actually looking for. And furthermore, you can say, well, I've got a class declaration syntax node, but what's its type symbol? Or I can just say, what's its symbol? And you'll notice that down at the bottom here, it now changed to a non-error named type symbol. Okay, so now that kind of tells you what the corresponding symbol would be for that node. Okay, so keep this tool in mind because I've found it to be so helpful when I'm building these things. Okay, so I now know what the source type is, and I know what the destination type is, and now I'm going to validate the pairs. What I mean by that is I want to look and see, and I'll kind of just skip down here because I don't want to go through every line of code on these things. What I'm trying to look now is to see on the properties of both the destination object and the source object, specifically their types. I'm going to look at their properties, and I'm going to look in the destination object. Specifically, I'm going to look for their setters. and determine, are they public? Okay, because if they're public, I might be able to set them. On the source, I want to find public getters. Okay. And then I just kind of look through both sides and determine, do I have any that have the same names and the same types? Okay. If I do have that, this is where you're going to start to see some C# code generated if you squint hard enough, because you're going to see the destination property name equal to, this was what the source is going to be called, its property name. Okay. You also notice I'm doing diagnostics add. You can create these things called diagnostics. So if you find a condition that comes up, like for example, this condition, this is saying I didn't find any matches between the two. And if that happens, I'm going to add a diagnostic that says, well, you're trying to map from one to the other. I didn't find anything that maps. So that's probably an error. And you want to go back and look at what's actually going on. Okay. So you can add diagnostics to a compilation, or I'm sorry, to a generator as well. Now, if I go all the way back to the generator, I can use this result of information and say, well, if I didn't have any errors in this perusal of the data, so to speak, what I'm now going to do is build the code. And in this case, the way I do it is I just use this class called Mapping Builder. These are just things I've built. They're just trying to arrive at the destination of source text. This is what you need to give to the context to say, I'm going to add new code to this compilation. Okay. So I have a source, I have a destination, I have the properties that map between them. I can actually use configuration values because I can look at things to say, well, what's the indent style that they're actually using in editor config or something like that? Do you use tabs? Do they use spaces? I want to honor that. So you can actually look that up in a generator as well. Indented text writer actually comes from system.codedom. So that allows me to kind of indent and outdent when I'm generating the code. So it's a little bit nicer to read. Now, as you start looking at what I'm doing here, you can see where I'm just literally generating C# code via strings. And I'm just putting in like namespaces that I need here and then putting the namespace here, declaring a partial class that uses the source type's name as well, creating an extension method here, and then doing a check to see, well, if the source is a reference type, it might be null. So I want to put a null check here. And then I'm going to put in all these maps. Okay, if I go back now to the example and I come up here, I say map to destination, you can kind of see now where this got generated from. Okay. That's all from what I'm doing in this piece of code here. Okay. And how you generate the C# code is completely up to you. There's a couple different ways you can do it. You can just do it through raw strings that I'm doing here. There is a NuGet package called Scribian, which is a C# templating engine. So you could actually use that within your generator if you want. You can use the compiler API syntax tree, build a whole new syntax tree if you want. That's pretty verbose, but that's another possibility. Doesn't matter as long as you get to a piece of text, a string, that you can pass into source text from. Okay. And once you have that, if we go back to the generator here, you'll notice that I'll return these results, which come down to here. I'll always report diagnostics because I want that to show up in the error list. But if I actually did get a name of a file and source text, I'm going to add that to the context. And that's what actually gets added here in my demo. And actually, if I take this now, I'm going to put it over here so you can see this. I go back down to the definition, like I said, reason wasn't there. Well, if I throw it up into source now, you'll detect that and pick that up and put that into the source generator, which it has to do before at some point, even when you do the compilation. If I didn't do an F6 at that point, but Visual Studio just kicks in and says, okay, I'm going to rerun the generator. And now I get that property there. And if I took it out, you'll notice that it goes away from the generated code. Okay. And this is C# code that's going to be included with your assembly. Okay. In fact, if I go to build here and I think, yeah, I'm in debug. If I put a breakpoint right here, okay, and I say actually not in the source generated code. Let me close that out. Let me actually put it here. Okay. And I'll run this example. If you want to do this, you can, because everything just works. There's no magic that happens here. It's just C# code that's got all the debug symbols in place. So when I F11 and step into this method here, it goes right to the source generated code. Yeah. So me as an author of the generated code, this is really nice for me to debug. But if you're using something that's creating source, you can also take a look at it and debug into it to see maybe if there's a problem with it. You can take a look at where it might be. Okay. So that's, in a nutshell, the core stuff of what you can do with source generators. And I'm going to check the chat real quick. One other thing I want to quickly mention is I'm a big fan of tests, and that we should be creating tests, and you can definitely create tests for your source generators. Okay. Again, look at the repo and dive deeper if you want to see how this works. But essentially, I can do things where if I go to the method that's actually doing it, I can say, well, here's a piece of code that I want to get a generator working on. So I'm just going to be using the stuff from the compiler API. I'm going to parse that text. I'm going to get a syntax tree. I can get a compilation from that syntax tree. I can look at all the syntax trees that currently exist there, so I can see if a new one's going to be added by my generator. I then create an instance of my generator, use this C# generator driver class from the compiler API, create one, and then call this run generators method. If the generator is successful, what's going to end up happening is that new compilation is going to have a new syntax tree in it. And I can use that to then test and see what is actually in that new code. Okay, so you can definitely test source generators in unit tests. All right, now just take a quick look here again and see. Oh, where's the chat? There's the chat. Lots of stuff here. Lots of stuff. I'm going to just, so much here. Source Generator Studio only. No, it is a .NET compiler thing. So it's not Visual Studio only. You can use it from the command line. If you actually use CSC, there's a way to say, I want to reference these assemblies such that they're analyzer assemblies, but the generators will kick in as well. So you can, you can use anything. Somebody noticed that I'm using Cascadia code. Yeah, that's a good point to make. Where was I actually doing it? Here, for example. So this is just the equals greater than. It's just Cascadia code has these ligatures so that it ends up looking like this. I kind of like it. It can look a little odd, but yeah, if that's where you're wondering they're coming from, is it's Cascadia code. Okay. Let's one more here. You got the questions for the video? Yes, I will. I'm trying to do that. I will keep that in mind. Let's see. Publish SARE project. Fortunately, I'm not sure. Not following what that is. Sorry. Watching the time here too. Okay. So sometimes with PostSharp. Oh, yeah. Somebody is mentioning PostSharp here. Is it possible reflection to tests? It can be nice just that a test and attribute has been applied. Is it possible reflection to test? You don't know if an attribute has been added rather than repeating a test for the attribute functionality. I'm not sure about that, David. I'm not sure if I don't quite understand the question. I will say this though, and I know this isn't what you're getting at, David, but when you mentioned PostSharp, it's interesting to note that PostSharp just announced a month or so ago that they are completely changing their engine. They basically forked the Roslyn compiler, and now everything is going to be based on their forked Roslyn compiler, such that all of their weaving is going to be done in pure C#. So kind of an interesting update. They said it's a huge change for them, but yeah, it's one that I think is a good one, the direction that they're going. So, all right. I'm just going to show a couple of other examples here just to give you a feel for, okay, I have to create, this this generator class and a receiver class, and I need to look for nodes in a tree, maybe look at the semantic model so I can look for types and properties and so on, whatever I'm trying to look for, and eventually generate a piece of text that's going to be source text, and that's what's going to be outputted as new source generated code. Okay, let's look at a couple of other things that you can do. I was spending some time with languages here and there. Pony is one of them. Python is another. Not experts in any of those. But one thing I noticed in those languages is that they have this thing called partial function application. Okay, we can basically say, I want to use this function where these arguments are always these values. And I thought, well, can I do this in C#? Specifically, can I do it as a source generator? I looked and I saw other people doing a similar approach by using the func and the action delegate types, which works, but those types can be a little bit limiting. In most cases, they're going to work just fine. But if you're using like pointer types, span of t, other things, they don't work with generics well. Also, if you have optional arguments, that doesn't work well as either. So I thought, could I do partial function application with a source generator? And this is what I ended up with. So I have partially apply maths, which hopefully with the audience, I tried to not use the Americanized math version. I also didn't want to collide with system.math, which currently exists in the .NET BCL. So I have this maths.add, okay? And that just looks like this, pretty straightforward, pretty simple. Okay? I also have a method in this class where I'm going to just add 3 values together, and they all have optional default values if I don't specify them. Okay. So coming back up here, I use this partially apply where I say this is my target function, and this is the value for the first parameter that I want to basically bind and say it's always going to be 3. So if I'd call increment by 3, passing in a 4, I should get 7. But this doesn't just work for static methods. If I have a class called functions and I new up an instance of that, and I call, and I not call, but I say I want to create a partial function application for multiply, which looks like this, okay? I can do that. And in this case, I'm always going to take whatever the other argument is and multiply it by 3. But I can also target a method that has optional values. And in this case, depending upon what I pass in to that resultant function, I can change the output. So let me run this first, okay? And I'll come back over here. If it would let me. Come on. There you go. Okay, let's do this and bring that up a little bit. So you can see here, we get 7, 4 times 3 is 12. If we don't specify any values, we're going to get 3 plus what the other 2 are. But if we start putting in values and not taking the optional arguments, the value from that add with 3 function is going to change. So how do I do this? Well, if I go to partially apply and F12 into it, that's what the generated code looks like. Okay. So this, it may be a little confusing at first, but essentially what I'm doing in this source generator, which again, I'm not going to dive into how it does what it's doing, but I'm just going to kind of describe what the end result is. I look at the function that's passed into me and I say, oh, it's a function that takes 2 arguments and returns an argument, both, or it returns a value. And all 3 of these are ints, okay? I also want to say that the first value is always going to be whatever A is. So what I can do is say, well, what I need to produce is a function that takes 1 integer, returns an integer, but always make on the original function the first value being A. Okay. And if you're a little confused by this new syntax, that's in C#9. That's called target type new, where you don't have to specify the actual type when you call new. If it knows what, if it can infer what it is, which in this case, it knows the return type here. So it knows what I'm trying to do here is create a new func where it takes 1 value and produces a value. It's just going to do a capture of the A value here, and then call whatever I passed in here. Okay, so if I go back to my example, it's A is 3 here, and it's going to pass that into the first value of maths.add. Same thing for multiply as well. With optional values, I have to be a little bit more creative because I can't use funcs or actions. So in this case, what I do is I can generate delegates that do the same thing for me. Okay. So I have these delegates that have all these optional arguments with their values preserved, and then I can call it here. Works the same way, except now I got the benefit of I can specify those values, or I can just use the optional values if I want to. And that's what I do in my source generator. I just look and say, oh, there's optional arguments. So in that case, I actually have to produce a delegate, define it, and then use that in the definition for this method. Okay. The last one, and then I'll look at questions again, is a library that I created called Rocks. This is a mocking library similar to an substitute or MOQ. So if you've used any of those libraries before for mocking, this should look fairly familiar. And if you don't like using mocks and tests, or you do, this isn't trying to get into an argument of which is better or not. Some people love to use them. Some people hate them. Some people are kind of in between. What I want to illustrate here is being able to create a mock with my library where I'm actually producing this whole API around the mock, which hopefully makes it a little bit easier to understand and reason about. Okay. So the intent of this demo here is I have, if I go down to here, I have a record, a customer, and I also have a way to retrieve a customer down here. But this class has a dependency on its constructor to this repository. Okay. So when I call get on the retriever, I'm actually calling retrieve on the repository. Okay. Probably a fairly basic example, but if you've done dependency injection, if you've done mocking before, this should feel somewhat familiar. Okay. Whereas when I want to write a test, I don't necessarily want to have an implementation of this interface. I just want to have something that I know will catch that I'm doing this in the way that I think my code should be working. In other words, I need to make sure that I'm actually calling retrieve here. Okay. So if I go back up to my code here, okay, and let's say that I want to create a mock of a customer repository. So libraries like MOQ and NSubstitute, what they would typically do is, and this gets into a really deep area, they're actually generating types on the fly. And they use libraries like MonoCecil or other libraries to actually generate an assembly using IL, or the intermediate language, which is very powerful, but it also is somewhat complicated. It's not something that people typically do when they're writing C# code. Okay, I've done demos where I ask people, do you know what IL is? And sometimes I don't get a lot of people to raise their hands, and that's perfectly fine. Some people, that they just look at .NET and go, I'm writing C# code. But underlying that C# code is intermediate language. Same thing for F#, same thing for anything that needs to run in the CLR. Okay. So that's complicated. What I did with Rocks initially 5 years ago is I said, okay, you've given me a type, this customer repository. So I need to generate a new type where I can catch that you're trying to call it and maybe return values that you're specifying and blah, blah, blah. And I'm going to write out all the C# code. And then I'm just going to use the compiler API to just build it and load it on the fly. So the end result was the compiler API wasn't used a lot at all, but it was nice that I could actually generate C# code. That made it easier to debug. When source generators came onto the scene, I thought, can I change Rocks so that I'm actually doing source generation at compile time, which I can. And that let me be a little bit more creative with how I'm specifying my expectations. For example, I want to state that I need to call retrieve on the repository. So you notice here I'm getting this rock.methods.retrieve. Okay. This methods is an extension method that's generated to say, hey, I want to set up an expectation on a method. So I go here called retrieve. And I need to make sure that I'm getting a specific value passed into it. And when that's called, I want you to return a value, specifically this customer object. Okay. But I also want to make sure that you're going to call the getter of the ID. And so I also have a way to say properties, getters, ID. And when that's called, you're going to return this value. Okay. So again, all this is just generated from the source generator itself. And as you can imagine, if you look at the source code, it's pretty complex to do this stuff. It took a while to finally get this all working. But at the end of the day, I get this so where I can have like the methods and the properties and have those kind of, separated out so I can find them a little bit easier. And then I can create instances of a mock with an instance method here. And if I was passing in a class that had a constructor with arguments, I'd also be generating instance methods here that I could have the arguments passed into the constructor as well. So those will be generated by my source generator. The code under test gets my mock, I call get, and then I verify that it all worked well. And if this is all good and I run this, well, nothing fails, which is good. But let's say I didn't call the getter on the property, okay? And I just put in 3 here, the original value. Well, what's going to happen now is I should get an error, and I do, because I noticed that there is a expectation that something didn't get called. And I realize the error message here is a little hard to read, but the point is that it's saying you missed something. Something didn't happen correctly in my test. Okay. So let me just, come on, go back to where you were, chunk.id. And let me just do let's do it right here. If I do an F12, again, this is all the code that's generated by rocks. Okay. So you can see here, this is that custom type that derives from the type that was given to me. And in the retrieve method, and then the delete method, because that's there as well, the property, the int property, the getter, I generate all this code to determine if you're calling it, if I need to return a value to make sure that that's being returned, to count how many times you're actually invoking that, because you can specify this should be called 5 times or something like that. And you can have an expectation set up that way as well. So you can use source generators to build an entire mocking library if you would like. That's a fairly deep one, but that shows you just how powerful these source generators, or the power that they enable to let you do these types of things. Yeah. All right, let me just check these again. So could just use F# for partially applying. Yes, you could. It's funny, I did a talk for the .NET Doc show, and I showed this example to them, and they said they just had somebody from, I think somebody talk about F# and somehow I guess they actually got in the conversation of, well, can C# do this? And then I showed what I was doing, and they said, wow, that's actually really close to what the person was talking about. So yeah, you're correct. I just thought it would be interesting to see if I could get something to kind of sort of work the same way in C#. What happens if I consume a source generator package in a non.NET 5 or later project? Well, if you're going to use like .NET Core 3.1 or .NET Framework 4.7, it's not going to work because the compiler doesn't know what those generators are. So they're just not going to do anything. You do have to be, you have to be consuming those generators in projects that are also .NET 5 and above. Okay. Can I generate just a few random statements into the context of an existing class? Example, in your customer retriever class, can I generate the field and the constructor that injects the repository? So can I generate a few random statements in the context of an existing class? No, you can't change code that it currently exists. You could, if the scenario you're looking for is I want to add a field or something like that, then as long as the original definition was a partial, you could generate a partial definition and include that field if you like. So that's one way you can do it. So yeah, when asking about limitations, that's the biggest one, is that you can't change existing code. You mentioned Proto earlier, define APIs using ubiquitous languages. Are there any source generators out there that you know of which might aid in generating abstract classes? Strongly define the structure, methods, expected results of an API. I don't know of any off the top of my head. Generating abstract classes, there might be. If you're talking specifically about gRPC and Proto, I know originally the support, they had to kind of handcraft it themselves, in that they'd have to look at a Proto file and then generate the C# code, but they weren't using source generators. That may have changed in recent history. I know also that Blazor in the next version, I think for .NET 6.0, they're changing all their stuff so that they're actually using source generators as well to like take a Razor file and generate the C# using source generators. So Steve Collins, that maybe he's getting at what you're asking about, Timothy. So anyway, all right. So I'm just going to finish up, and then we probably have time for some other questions. Let me get back to here. All right. So again, went through the mechanics of a source generator, the generator class itself, the receiver and how that can help you filter out things, and then what you do with that is completely up to you. You just need to get to the end result of creating source text. That's really what you need to do. And then it all just gets magically built in for you. And it's not specific to Visual Studio. It's not specific to just Windows. This is all for just .NET 5 and beyond. Okay. For anybody out there, by the way, that's using Visual Basic, this is just C# only. Apparently, this is going to be added in .NET 6 so that VB is supported as well. But I haven't done Visual Basic in a long time, so I'm mostly just focused on C#. Okay. All right. So where do you go from here? The thing I would really stress is to think about, not stress about thinking, but to really think about places in your code, things that you're doing in your applications, and just sit there and go, what happens if I took this and did this so that it's using a source generator? Would that make my life easier? Would that make something faster? In fact, I mentioned faster. And since I mentioned faster, I totally forgot to show this. I'm going to mention this real quick here. So I mentioned, the whole speeding up things. In this inline mapper, I did just this quick performance test where I said, what does my inline mapper compare to doing something like reflection, like that code I showed in the slide before? And what does it look like compared to AutoMapper? Okay. And it's not like I'm trying to beat AutoMapper. I was just wondering what would happen if I use benchmark.net to kind of compare a reflection approach, my inline mapper, and AutoMapper itself. And what I found was that the inline way is the fastest and also allocates the least amount, which shouldn't be surprising, because while AutoMapper is really optimized, it still has to do some like expression generation or reflection generation. I'm not actually sure what it does underneath the scenes. I know it's very optimized, but even with that, it can't beat generating the source code. Okay. So maybe AutoMapper in the future will actually change to using source generators, and then it would get that benefit as well. Okay. And so that's what I'm getting at here, is to think about where you can start changing stuff to use source generators. There's a bunch of examples I've seen out there already that are doing all sorts of amazing, cool things with source generators. The one at the top left, Blazor routes, I think that came from Andrew Locke. And if I'm misquoting the source, I apologize. But I saw this article where somebody said, hey, I've got a Blazor app, and I've got all these page directives in my components. And I know page directives essentially turn into route attributes on C# classes. Could I take a source generator and look through all my code and find out where all the route attributes are So I can generate a structure that says, for my application, here are all the supported routes that you can go through. It essentially sets up almost like a Swagger open API possibility for a Blazor application. So you can say, hey, if you just go to these routes, I know these are supported, and it would go to essentially this view. That was really cool. I thought that was such an interesting idea. I really like that example of using source generators, and maybe you'll come up with one yourself. So again, on this last slide, if you look in the notes, take a look at some other references. You can kind of see them down here and check out what they're doing and what they have there available in their URLs. I'm actually done with my talk, so I want to say thank you everybody for joining. I hope this has been interesting and helpful. And again, maybe it's sparked something in your head to go, I think I'm going to look at this and do something later on. Okay. So I am done.
Cool. Before I do the outro, does anyone have any questions? I don't know whether, I know Jason was asking, answering questions as we went along.
I tried to. I tried to. My head hurts. Yeah, Adam, I'm glad that you said that, because this isn't an easy topic. I will readily admit that it's something that can get very complicated. So if your head hurts, I totally understand. The power of this, though, is that if you do spend that time to kind of go through some of the playbooks that they have and the cookbooks from the Roslyn team, from the C# team, and look at what they're doing as well. Take a look at other examples. Maybe things will start to click in your head and go, okay, now I can kind of, like, doing this in an hour, no matter how I try to do this, it can be, especially if you've never seen any of this stuff before, it can be somewhat overwhelming. But, I hope that doesn't discourage you. Just keep researching and looking, and hopefully you'll be able to use some of this in your stuff. The revised edition. Yeah, I wrote a book on metaprogramming and .NET, co-authored one. I'd love to do a second edition, but time and money, that always gets in the way. So,
well, this is going to be very interesting if we do this podcast episode, audio only, explaining this.
Yeah, doing audio only of any, especially this could be, okay, if you would see the screen, you'd see the generated code, and well, I can't see it. So it can be pretty hard. So
it'll be good fun. Any other, feel free to unmute yourself. Oh, sorry, Stuart.
Yeah, I got a question. I've been doing a bit of metaprogramming recently for a recent project, and I've got the need where I'm working against reflection APIs and also the Roslyn APIs for source generation, and I want to kind of be able to reuse a bit of both. And I can't see out there if there's any sort of abstraction that kind of, because the APIs look similar, although the Roslyn ones are a bit nicer. I don't know if you've come across any sort of abstractions that try to unify those two worlds.
So there really isn't. I get why you're asking, because if you think, one way to think about it is you have your syntax trees. That's just like the raw information about your code. And then you have the semantic model, which is on top of it, where it feels more like reflection. It's easier to look at and get your head around what's there. And then there's reflection. The thing about those is that they're in two different domains. Reflection really happens at runtime, whereas these two happen at compile time. So, the syntax and semantic models are there for you when you're doing compilation. But once you emit the assembly and load it, that's all gone. And so the only thing you really have there is reflection. Now you can use reflection, like you said, if you're building something with an analyzer or code fix or source generator, if that need arises, you can do that. But to have like an abstraction between the two, I don't think you're ever going to see that, because they just live in two different worlds. So yeah, I don't know of anything that would do that.
Thank you.
Okay. There's somebody asking, this looks ideal for defining dependency properties. And has anyone built a generator? Well, guess what, Steve? If there isn't, that's an opportunity. I look at that as an opportunity. I don't know of anything. There is, let me make sure that when I keep referring to these references, yeah, the references that I have in my notes section, there's one of them that's called, yeah, I just lost it. Where there, come on, there it is. You'll see something called a list of C-sharp source generators. I'll actually post this in the chat so everybody can see it. This person was keeping a list. I don't know how updated it is, but it's keeping a list of all these things that the person found, and maybe there is something there. So if there's not, be interesting to see, if there was a way to define a dependency property in something like UPF, or I'm sorry, WPF.
Cool. Shall we? So just a big thank you, Jason, for joining us. It's been amazing having you on. I'm so glad that's been recorded, because I think I'm going to have to watch that a few times to actually soak it in, especially before, if we do a podcast episode before that. So I know what we're talking about.
Again, thank you for having me. I really appreciate it. And for anybody, if you got questions that come up later, just send me, I'll put that also in the chat just one more time. Just send me an email at this address and I'd be happy to talk to you offline.
And we can include links to the notes that go on .NEToxford.com and any links we've spoken about as well. Okay. And also, actually, speaking of podcasts, I mentioned to you earlier that I saw that you popped up in the, was it Adventures in .NET podcast in my feed today?
Yep, that just popped up today too. So
I'm looking forward to listen to that on my morning walk, I think.
Okay, cool.
And thanks again, Matt, for doing an awesome intro talk. I'm mentioning Everstack and the podcast and all this kind of thing. I think you need to be my PR person, I think. Although I think I do need to up my game with my green screen, with a green screen now. You've got your shiny new green screen.
But if I do your PR, do I get a salary? Is that
what?
What? No, there's no pay for this. What?
I'd also like to echo what Matt said in the intro talk. A big thanks to our sponsors like Curriculo and Everstack, and also our prize draw sponsors JetBrains, Manning and Packet, and a big congrats to the winners. And thank you for everyone for attending. We do keep this event open as a virtual pub session afterwards, so feel free to hang around. Jason, I know you said you had to shoot off at past, but are you free for a quick virtual beer?
Yeah, virtual beer is water. I can stick around for about another 10-15 minutes. I would love to have a beer, but I just can't. So, but I'll stick around for a little bit. Yeah.